Hello, hi everyone. Welcome to the Student the Brand. This is our Shiva sir. Today topic is light reflection and refraction. Light reflection and refraction. Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. So here today now we are discussing about light reflection and diffraction. So here you can see. So this is the plane mirror. Light reflection and diffraction. Light reflection and diffraction. Light reflection and refraction. Reflection and refraction. Light reflection and diffraction. Okay. So when light incident on it. Okay. So hi everyone, welcome to the class. So this is the incident ray. The light ray which is incidenting on the surface is called incident ray, and the light ray which is reflecting back is called reflected ray, and the light ray which is reflecting back is called reflected ray, and the light ray which is perpendicular to the plane surface is called normal line. So we are drawing with the dotted lines. So that is a normal line. Okay, so normal line you can see here. Understood? So incident ray, reflected ray, normal line. Incident ray, reflected ray, and normal line. The angle between incident ray and normal line is called angle of incidence. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Okay, so you can see here. I hope it is very clear now. Okay. Right? Yes. Now it is clear. So here you can see incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. The angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. And this is the undeviated line. This is the undeviated line. Okay, undeviated line. The angle between reflected ray and undeviated line is called angle of deviation. Angle of deviation. Once again, you can observe here. So incident ray, this is normal line. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. And angle between reflected ray and undeviated line is called angle of deviation. So the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Reflection of light. Okay. So here you can see, coming to loss of reflection. Loss of reflection, there are two types of loss of reflection are there. Loss of reflection. Loss of reflection. There are two. So here, loss of reflection. Loss of reflection. So coming to point number 1, loss of reflection. Point number 1, incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. So point number 1. Coming to point number 2, angle of incidence is equal to angle of reflection. So loss of reflection, coming to loss of reflection, incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. Lies on the same plane. Angle of incident is equal to angle of reflection. So these are the loss of reflection. Loss of reflection. So you can see here, you can observe this angle, linear angle. So I am taking this linear angle. Linear angle is how much? 180 degrees. So it is include of, so this angle is including of angle of incidence plus angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. 180 degrees. You can observe angle of incidence plus angle of reflection plus angle of deviation equal to 180. This is a linear angle. Right? Yes. Now, in that case, so from loss of reflection, what we can take? Angle of incident is equal to angle of reflection, right? From loss of reflection, angle of incident is equal to angle of reflection. So that angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. Yes or no? Angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. So we can write angle of deviation equal to 180 minus 2 angle of incidence. Angle of incidence equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. Here, in the place of angle of reflection, I am substituting angle of incidence so that we are getting angle of deviation equal to 180 minus 2 angle of incidence. Okay. And in the place of angle of incidence, I am substituting angle of reflection then. So I got this value. Right. Angle of deviation equal to 180 minus 2 angle of reflection. I hope it is very clear. I hope it is very clear. Right. So incident ray, reflected ray, normal line and undeviated line. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of deviation. Angle between reflected ray and undeviated line is called angle of. So angle between reflected ray and undeviated line is called angle of deviation. Okay. So I hope these are the points. I hope it is very clear. Right? Yes. So now loss of reflection. Coming to loss of reflection, incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. Angle of deviation equal to 180 minus 2 angle of incidence. And angle of deviation equal to 180 minus 2 angle of reflection. So like this we can write. Right? Now, so we'll discuss about regular reflection. Now we will discuss about regular reflection and irregular reflection. So what do you mean by regular reflection and irregular reflection? Regular reflection is nothing but incident light rays are parallel, then reflected light rays are also parallel to each other. The type of reflection is called regular reflection. Coming to irregular reflection, incident light rays are parallel but reflected light rays are not parallel to each other. The type of reflection is called irregular reflection, right? Yes. So regular reflection and irregular reflection. Now you can see here. So I am taking this a plane mirror. This is a plane mirror. So incident light rays are parallel. These are incident light rays. Incident light rays are parallel, then reflected light rays are also parallel to each other. This type of reflection is called regular reflection. Regular reflection. Regular reflection. Regular reflection. Regular reflection is incident light rays are parallel, then reflected light rays are also parallel to each other. So here you can see these are the reflected light rays like this. So these are parallel, then these light rays are also parallel to each other. This type of reflection is called regular reflection. Regular reflection. Coming to irregular reflection, okay, so irregular reflection, so you can see here like this, you can observe. So incident light rays are parallel but reflected light rays are not parallel to each other. Incident light rays are parallel. These are the incident light rays. Few questions also will discuss. So these are the reflected light rays. These light rays are moving in different directions. These light rays are moving in different directions like this. Okay, regular reflection and irregular. So incident light rays are parallel but reflected light rays are not parallel to each other. Incident light rays are parallel but reflected light rays are not parallel to each other. This type of reflection is called irregular reflection or diffused reflection. Irregular reflection or diffused reflection. Okay, diffused reflection. So I hope it is very clear. So this is about regular reflection and irregular reflection. Now we will discuss about object and image. Now I will discuss about object and image. So generally on plane mirror, on cinema screen, on wall, what type of reflection takes place like this? They will ask questions on this concept. And coming to reflection of light, when light ray is passing along the normal line, if the light ray passes along the normal line, it reflects back in the same direction. So that time, so angle of incidence, angle of reflection, so angle of incidence how much, angle of reflection is how much, and angle of deviation how much, like this they will ask questions. And sometimes if they ask, they will ask about loss of reflection. So definitely they will ask the question about loss of reflection, and related to that one problem, like one problem may give like MCQ's point of view, like that. Generally theory question only they will ask related to reflection of light and loss of reflection. And sometimes one more also they will ask, that is uh, angle of incidence, angle of reflection, and angle of deviation, like this. Okay, so now we will discuss about one more, that is object and image. So object and image, so I am taking like this, object and image. So you can observe, so from here light rays, from this point light rays are coming, Okay, so here after reflection, so here there is a virtual image and this is a real object. Real object and virtual image. Observe carefully here. Observe carefully here. Okay, so from this point light rays are coming. After reflection, those light rays are moving away from the principal axis. If you are extending this reflector light rays, extended reflector light rays are meeting at one point. Extended reflector light rays are meeting at one point. Their image is forming. That is virtual image. Extended reflector light rays are meeting at one point. Their image is forming. That is called virtual image. That is called virtual image. I hope it is very clear, right? Virtual image. Okay. So this is the real object. So the point of intersection of extended reflector light rays. So reflector light rays are meeting at this point. Reflector light rays are meeting at this point. So that is a virtual image. That is a virtual image, right? So this is a real object. Now so here you can observe we are extending these light rays. These are the incident light rays. Incident light rays. So I hope it is very clear. Once observe here. This is the incident ray 1, I1, I2, R1, R2. And here also this is I1, I2, R1, R2. So you can observe here directly reflector light rays are meeting. Directly reflector light rays are meeting. So their image is forming. That image is called a real image. That is called real image. So here we are extending the incident light rays. Extended incident light rays are meeting at one point. That is a virtual object. Virtual object. I hope it is very clear. I hope it is very clear. Just check once here. Check once here. Okay. So you can check here. 1, 2. Incident ray 1, incident ray 2. So after reflection, those light rays are moving away from it. After reflection, those light rays are moving away from it. Okay. So those reflector light rays are meeting at one point. Those reflector light rays are meeting at one point. Okay. So here the image is forming. That is a virtual image. Here image is forming. That is a virtual image. And here you can observe. So these are incident light rays. After reflection, those light rays are meeting at one point. After reflection, those light rays are meeting at one point. That is a real image. If you are extending the incident light rays, extended incident light rays are meeting at one point, their virtual object is there. Virtual object is there. So if you conclude that, so you can observe like this. Object is real. So object and image. So object is real. Image is virtual. Object is virtual. Image is real. Object is real. Image is virtual. Object is virtual. Image is real. Okay. So that's enough. That's enough. Just once again. So I1, I2 after reflection those are moving away from it. If you are extending those reflector light rays are meeting at one point. Their image is forming. That is a virtual image. So here you can see incident ray 1, incident ray 2. After reflection, those light rays are meeting at one point. So their image is forming. That is a real image. So if you are extending these incident light rays, extended incident light rays are meeting at one point. That is a virtual object. Virtual object. Extended incident light rays. I1, I2. We are extending the incident light rays. Their image, there the point is virtual object. Virtual object. Okay. So I hope it is very clear. I hope it is very clear. That's enough. So next one we'll discuss about Now, so I'm taking here, so plane mirror, this is a plane mirror, so object, this is a object, okay, so this is a object AB, so one light ray I'm taking. So normally if the light ray is passing along the normal line, if the light ray is passing along the normal line, it retraces its original path. If the light ray is passing along the normal line, it retraces its its original path in the same direction. Okay, so here you can see one light ray is I'm taking like this, another light ray it will be reflected back. So like this I'm taking, and here also one more light ray. So if you are extending those light rays, those extended light rays are meeting at one point. If you are extending these light rays, extended light rays are meeting at one point, here you can see. So this is a reflected ray, so these are meeting at one point, okay. So A dash and B dash, A dash and B dash, A dash and B dash. I hope it is very clear. Okay, so now first point is object is real, image is virtual, object is virtual, image is real. So point number one, the distance between object to mirror, the distance between object to mirror, that is called object distance. The distance between object to mirror is called object distance, and the distance between mirror to image is called image distance. So object distance is equal to image distance, and the third one is height. This is the height of the object, and height of the image. So height of the object is equal to height of the image. And fourth one, so what is the fourth one? Next one is, so magnification of the plane mirror is +1. And fifth one, so it also shows lateral inversion. Lateral inversion. So lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. Okay, so once again you can see object is real, image is virtual, object is virtual, image is real, object distance is equal to image distance, height of the object equal to height of the image, and magnification of the plane mirror is +1. It also shows lateral inversion. So what is lateral inversion? The phenomena of converting of right side of the object appears to be left side of the image. The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. This mirror image is called lateral inversion. Okay. So next. Next we will discuss about spherical mirror. Spherical mirror. Okay. So now you can see spherical mirror. The mirror which is in the form of curved surface. So here there are two types. One is concave mirror, another one is convex. Concave means whenever the light rays are incident on it, after reflection those light rays are meeting at one point. Here you can see. So here if you observe, so whenever light rays are incidenting on it, after reflection those light rays are moving away from it. Okay, so here you can observe. In this case, after reflection those light rays are coming closer. So this is called concave mirror. Concave mirror. Concave mirror. So this one is a convex mirror. Convex mirror. So concave mirror and convex mirror. So after reflection, those light rays are meeting towards the principal axis. Here, after reflection, light rays are moving away from the principal axis. So concave mirror is also known as converging mirror. Convex mirror is also known as diverging mirror. So whenever light rays are incident, those light rays are moving towards the principal axis. So here, after reflection, those light rays are moving away from the principal axis. Okay, done. Now, so do like, share and subscribe to Student the Brand. Now we will discuss about terms related to spherical mirror. Terms related to spherical mirror. Okay. So terms related to spherical mirror. Let's start. Here I am saying so this is the center of the imaginary sphere. Center of the imaginary sphere in which mirror is a part. So center of the imaginary sphere. Center of the imaginary sphere in which mirror is a part. So midpoint of the mirror is called pole. So first one is center of curvature, second one is pole, third one is the line joining of center of curvature and pole is called the principal axis. The line joining of principal axis. The line joining of center of curvature and pole is called principal axis. Okay. So the distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole is called radius of curvature. Radius of curvature. After reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays will meet at one point on the principal axis called focus. After reflection, all light rays will meet at one point on the principal axis is called focus. Okay, so I am taking this focus. And so the distance between focus to pole is called focal length. The distance between focus to pole is called focal length. Okay. So you can see. So fourth one, principal axis, radius of curvature. Fifth one is focus. Sixth one is focal length. And seventh one is aperture. Aperture is nothing but a reflecting surface. Diameter of the reflecting surface is called aperture. Diameter of the reflecting surface is called aperture. Once again, center of the imaginary sphere. So center of the imaginary sphere in which mirror is a part is called center of curvature. The midpoint of the mirror is called pole. So you can see this is the midpoint of the mirror is called pole. The line joining of center of curvature and pole is called principal axis. And the distance between center of curvature to pole is called radius of curvature. So after reflection, all light rays will meet at one point on the principal axis called focus. The distance between focus to pole is called focal length. And width of the reflecting surface is called aperture. Width of the reflecting surface is called aperture. So these are the terms related to spherical mirror. Terms related to spherical mirror. Now we will discuss about ray rules of concave mirror and convex mirror. Ray rules of concave mirror and convex mirror. Ray rules of concave mirror and convex mirror. Okay, terms related to spherical mirror we discussed. So center of curvature, pole, focus, focal length, radius of curvature, aperture, okay, principal axis, all those points we discussed. So now we will discuss about ray rules of concave mirror and convex mirror. So I am taking this concave mirror. Okay, so here pole, focus, center curvature, pole focus and center curvature. So light ray is coming from infinity after reflection passes through focus, point number 1. So coming to point number 2, so pole, focus, center curvature, light ray is passing through focus. Yes, I will take classes every day. So do like, share and subscribe my channel. Please support the channel. Inform to everyone, share to everyone. So every day I'll be taking classes, live classes. Okay, so join to the classes. So topics will be explained and concept will be explained. Based on that one, we will discuss about questions also. So please do like, share and subscribe. Support the channel. Okay, share it to your friends. Ask your friends to join to the class. Share to everyone. Okay, so in our school who are there, okay, ask them to join to the class. Listen the class. If they like the channel, if you like you, if you like the channel, if you like my explanation, so please do like, share and subscribe. And if you are liking the video, just go for a super chat, super thanks and a membership also. Okay, thank you. So here one more light ray I am taking, it passes through focus. So light ray is passing through focus, after reflection moves towards infinity. And third one, so pole, focus and center curvature. This is the pole, focus, center curvature. Light ray is passing through center curvature, after reflection it retraces its original path. Coming to the fourth one, so here I am taking pole, focus and center curvature. This is the pole, focus, center curvature. A light ray is incident at the pole. It reflect back. So these are the concave mirror ray rules. Light ray is coming from infinity, after reflection passes through focus. Light ray is passing through focus, after reflection moves towards infinity. Light ray is passing through center of curvature, it retraces its original path. Light ray is incident the pole, it reflects back. So this is a concave mirror. Coming to the convex mirror. Okay, so here you can see. So I am taking the convex mirror like this. So pole, focus and center of curvature. Pole, focus and center of curvature. Light ray is coming from infinity, after reflection. So it passes through focus. So you can see here it passes through focus. So second one, so pole, focus and center of curvature. Pole, focus and center of curvature. Light ray is passing through focus. After reflection it moves towards infinity. Coming to the third one, light rays so passing through for center of curvature, pole, focus and center of curvature. Light ray is passing through center of curvature, it retraces its original path. Okay, so here you can see light ray is coming from infinity, after reflection passes through focus. Light ray is passing through focus, after reflection become parallel to the principal axis and moves towards infinity. Light ray is passing through center of curvature, it retraces original path. And coming to the fourth one, here you can see, so pole, focus, center of curvature. Pole, focus and center of curvature. Light ray is incident at the pole, it reflects back. Okay, so these are the ray rules. Ray rules of concave mirror and convex mirror. Light ray is coming from infinity, after reflection passes through focus. The light ray is passing through focus, after reflection moves towards infinity. Light ray is passing through center curvature, it retraces its original path. Light ray is incident at the pole, it reflects back. Light ray is incidenting at the mirror, after reflection passes through focus, convex mirror. Light ray is passing through focus, after reflection moves towards infinity. And here light ray is passing through center of curvature, it retraces its original path. Light ray is incident the pole, it reflects back. So this is about concave mirror and convex mirror. So ray rules. So these are the ray rules. Now we will discuss about image formations. So image formations are very very important. So you have to observe one thing. So not only image formations. So first you need to understand the positions where the object is placed, where the image is formed. Okay. So after that diagram everything. So in the exam they will ask about positions and the nature of the image. Okay, where the image will form. So they will give in the form of theory. So theory wise they will ask questions. So you have to give the answers, right? Now we will discuss about image formations by concave mirror. Image formation by concave mirror, right? Let's start. Concave mirror. So I'm taking here this is a concave mirror. Concave mirror. So every time when you are drawing the diagram, you must place full focus, center of curvature, and you have to place the object. Object is placed at infinity. How many light rays are required to form the image of the object? Minimum light rays are required to form the image of the object. Minimum 2. Okay. So I am taking one light ray here. So one light ray is parallel like this. Another light ray is like this. After reflection, those light rays are meeting at focus. Here, the light ray is meeting at focus. So here you can see. Okay, so like this and like this also. Okay, object is at infinity. Image is formed at focus. Nature of the image is real and inverted. Nature of the image is real and inverted, and size of the image is highly diminished. So point number 1. Coming to the point number 2. Object is placed. So here you can see. So pole, focus, center of curvature. Pole, focus and center of curvature. Object is placed beyond center of curvature. Okay. Object is placed beyond center of curvature. So here I am placing the object. So how many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays are required to form the image of the object. Yes. So I am taking one light ray like this. So after reflection it passes through focus. Another light ray is passing through center of curvature. Okay. So the image will form between C and F. So daily live classes will be going on. Inform your friends, ask your friends to join to the class. Okay, so definitely will be taking. So now you can see object is placed beyond center of curvature. Image will form between C and F. Object is placed beyond C. Image will form between C and F. Nature of the image is real and inverted. Size of the image is diminished. Compared to the object, image size is decreased. So that is the second image formation. Coming to the third one, here you can see. So object is placed. So in this first case, object is placed at infinity. Image is formed at focus. Nature of the image is real and inverted, and size of the image is highly diminished. So in the second case, object is placed beyond center of curvature. Image will form between C and F. Nature of the image is real and inverted. Size of the image is diminished. And in the third case, object is placed so at center of curvature. Image also will form at center of curvature. One light I am taking like this. It passes through focus. Okay, so another light ray is incidenting at the pole. So those light rays will meet here at center of curvature. Okay, object is placed at C. Image also will form at C. Nature of the image is real and inverted, and size of the image is same size. Okay, so this is the third one. So very very important. So in the on third one, so there is a question. So what is the minimum distance? I'll ask one question. What is the minimum distance between object and its real image in the concave mirror? What is the minimum distance? What is the minimum distance between object and its real image in the concave mirror? So let me know the answer. What is the answer? Answer is 0. So in this case only, object and image will form at same place. Okay, object and image will form at same place. So that's why, so same size. Object is placed at C, image also will form at C. Nature of the image is real and inverted, and size of the image is same size. Okay, so I hope it is very clear. So this is the third one. Coming to the fourth one. So a pole, focus, center of curvature. Object is placed. Okay, object is placed between C and F. So one light ray I am taking like this, it passes through focus. Another light ray is sorry. One light ray is incident, after that it reflect. So another light ray is passing, so you can take like this. The image will form beyond center of curvature. Object is placed between C and F. Image also will form beyond center of curvature. Object is placed between C and F. Image will form beyond center of curvature. Image will form beyond C. Nature of the image is real and inverted. Size of the image is enlarged. Compared to the object, image size is increased. Okay, image will form here. So next one, fifth one. So here object is placed. So this is the pole, focus, center of curvature. Object is placed at F. So image will form at infinity. One light I am taking like this. Another light ray is incident at the pole. So object is at F. Image will form at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged, because point size image, so enlarged, highly enlarged image is formed at infinity. Okay, object is placed at F, image is formed at infinity, nature of the image is real and inverted, size of the image is highly enlarged. So that is the fifth one. And coming to the sixth one is very very important, because virtual erect and enlarged image will form in this case. So you can see here. Pole, focus, center of curvature. Object is placed between F and P. One light ray I am taking like this, it passes through focus. Another light ray is incident at the pole, it reflects back. So if you are extending these light rays, the image will form here. The image will form behind the mirror. Okay, so nature of the image is, so object is placed between P and F. Image will form behind the mirror. Nature of the image is virtual erect. And erect. Size of the image is enlarged. I hope it is very clear. Once again check here. Object is placed at infinity. Image is formed at F. Nature of the image is real and inverted. Size of the image is highly diminished. And coming to the second one. So in this case, object is placed beyond center of curvature. Image will form between C and F. So nature of the image is real and inverted. Size of the image is diminished. And in this case, object is placed at C. Image also will form at C. Nature of the image is real and inverted. Size of the image is same size. And the fourth one, object is placed between C and F. Image will form beyond center of curvature. Nature of the image is real and inverted. Size of the image is enlarged. And in this case, object is placed at F. Image will form at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. And in this case, the last case is very important. So this question will come for 3 marks. So practice once carefully. Definitely this question will come. Okay, object is placed between F and P. Image will form behind the mirror. Nature of the image is virtual, erect and enlarged. Virtual, erect and enlarged. Virtual, erect and enlarged. So 3 marks question. So applications also very important. Applications also very important. Make sure that you are learning all these points. Okay, next. Convex mirror. So now completed concave mirror. So now we will discuss about convex mirror. So in convex mirror only 2 cases are there. In convex mirror only 2 cases are there. Those are so pole, focus, center of curvature, pole, focus and center of curvature. Object is placed at infinity. So how many light rays are required to form the image of the object? Minimum 2 light rays. So one light ray I am taking like this. After reflection, those light rays are moving away from it. Okay, so another light ray I am taking like this. So it passes through focus. Object is at infinity. Image is formed at focus. Object is at infinity. Image is formed at focus. Nature of the image is virtual and erect. Size of the image is highly diminished. So object is at infinity. See, so in convex mirror, so object is placed at infinity, image is formed at focus, nature of the image is virtual, erect and highly diminished. So this is the first case. Coming to the next one, so here you can see, so object is placed, so here pole, focus, center of curvature, object is placed here like here. So one light ray I am taking like this. After reflection, those are moving away from it. Another light ray is inciding at the pole, it reflects back. So here if you are extending these light rays, those light rays are meeting between P and F. Object is placed between P and infinity. Image will form between P and F. Nature of the image is virtual and erect. Size of the image is diminished. So compared to the object, image size is decreased. Okay, so in the first case, object is placed at infinity. Image will form at focus. Nature of the image is virtual, erect and highly diminished because point size image is formed at focus. So here in this case, object is placed between P and infinity, image between P and F, nature of the image is virtual, erect and diminished. Okay, so in these 2 cases, object is placed, okay, so image will be formed virtual, erect and diminished. So if you place this mirror in front of any object, we can able to see full view of the object. And coming to the field view, okay, field view is more for convex mirror. So for this mirror only, field view is more. The region between 2 extreme reflector light rays is called field view. Okay, and here for compared to concave mirror and plane mirror. So field is more for convex mirror. That's why we are using in side view mirror, rear view mirror. So cars side view, rear view mirror, and vehicles rear view mirror like bikes, cars. So that we can able to see the full view of the traffic. Okay, so we can see the full view of the object. Okay, so this is the importance of the convex mirror, right? Next, sign conventions. Sign conventions. Sign conventions. Okay, sign conventions, if you see, sign conventions. So now you can observe. So I'm taking the concave mirror like this. This is a pole, focus, center of curvature. Pole, focus and center of curvature. All measurements will be taken from the pole. In the direction of incident rays, all are positive. Opposite incident rays, all are negative. Above the principal axis, all are positive. And below the principal axis, all are negative. All measurements will be taken from the pole. All measurements will be taken from the pole. In the direction of incident rays, all are positive. Opposite incident rays, all are negative. Above the principal axis, all are positive. Below the principal axis, all are negative. Okay. New Cartesian. New Cartesian. Sign convention. New Cartesian. Sign convention. All a distance measured from the pole. Distance positive along the incident rays. Distance negative opposite to incident rays. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian. New Cartesian. Sign convention. New Cartesian. Sign convention. All distance measure from the pole. Distance positive along the incident rays. Distance negative opposite to incident rays. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian. Okay, so here you can see. So I am taking this a positive x-axis, negative x-axis, positive y-axis, negative y-axis. Okay. So all measurements will be taken from the pole. In the direction of incident rays, all are positive. Those are object distance, image distance, focal length and radius of curvature. Opposite to incident rays, all are negative. Above the principal axis, all are positive, and below the principal axis, all are negative. Okay, so this is about new Cartesian sign conventions. New Cartesian sign conventions. I hope it is very clear. So next one we will discuss about mirror formula, magnification. So mirror formula 1 by f equal to 1 by v plus 1 by u. and magnification equal to height of the image by height of the object. That is nothing but minus v by u. Okay, so minus v by u. So this is about mirror formula and magnification. So based on that one, few problems we'll discuss, few questions we'll discuss. We have to discuss. There are few questions are left. So let's start. Okay. So few points. So state the laws of reflection of light. Okay. So now define reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. So the bouncing back of the light from the reflecting surface is called reflection of light. State laws of reflection of light. What are the laws of reflection? Incident ray, reflected ray, normal line lies on the same plane, and angle of incident is equal to angle of reflection. Okay. Next one, define regular reflection and irregular reflection. Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. So regular reflection means the incident light rays are parallel, the reflected light rays are also parallel to each other. That type of reflection is called regular reflection. Incident light rays are parallel but reflected light rays are not parallel to each other. That type of reflection is called irregular reflection. List the characteristics of the image formed by the plane mirror. If the object is real, image is virtual. If the object is virtual, image is real. Point number 1. And object distance is equal to image distance. Height of the object is equal to height of the image. And next one, magnification of the plane mirror is +1. And it also shows lateral inversion. The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. Okay. So name the phenomena responsible for the following effect. When we sit in front of a plane mirror and write with our right hand, and it appears in the mirror that we are writing with the left hand. So lateral inversion. So what type of image is formed in the plane mirror? What type of image will form in the plane mirror? Virtual image. On the plane mirror, virtual image. On cinema screen, real image. On cinema screen, real image. And coming to the differentiate a real image from a virtual image by giving 3 points of difference. Okay, once again, differentiate a real image from a virtual image by giving 3 points of difference. Real image. If the light rays after reflection converge and meet at 1 point, so virtual image. So extended reflected light rays are meeting at 1 point. So real image can be formed on the screen. Virtual image cannot be formed on the screen. A real image always inverted. A virtual image, it will be erect. So real image formed by concave mirror. Real image will be formed by concave mirror and convex lens. Yes, that's enough. Coming to the virtual image, all the mirrors. Example, concave mirror, convex lens and concave lens. Because in concave mirror, last case virtual image. In convex lens, last case virtual image. Remaining 2 mirrors anyway it forms virtual image. Right? So what is the radius of curvature of the plane mirror? Radius of curvature is infinity. What is the power of the plane mirror? Power of the plane mirror is 0. What is the value of speed of light in space? What is the value of speed of light in space? 3 into 10 power 8 meter per second. Which type of reflection of light leads to the formation of images? Which type of reflection of light leads to the formation of images? Regular reflection. And what is the difference between regular reflection of light and diffused reflection of light? In regular reflection of light, incident light rays are parallel, then reflected light rays are also parallel to each other. That is called regular reflection. Coming to irregular reflection, incident light rays are parallel but reflected light rays are not parallel to each other. Okay. So next one, what type of reflection of light takes place from a cinema screen? On cinema screen, what type of reflection? Regular or irregular? Irregular. Plane mirror. On plane mirror, what type of reflection of light? On plane mirror. Can anyone say? On plane mirror, what type of reflection? Plane mirror. Plane mirror. What type of reflection of light takes place? What regular or irregular? On plane mirror. On plane mirror, regular reflection. On cardboard, regular or irregular? On cardboard, irregular reflection. And still water surface of lake, regular reflection. And a wall reflect light and mirror also reflect light. What difference is there in the way they reflect light? A mirror has highly polished surface which is smooth when parallel beam of light incident of okay, so then reflector light rays also remains parallel. So this type of reflection is called, on best example, on wall irregular reflection, on plane mirror regular reflection. Regular reflection, incident light rays are parallel, then reflector light rays are also parallel. But coming to the irregular reflection, incident light rays are parallel, but reflector light rays are not parallel to each other. Okay. Okay. Next, under what conditions in an arrangement? So this question anyway knows. So already given. And so that's enough. So we'll do problems. So we'll do a few problems related to mirrors. So plane mirror like this. Okay. So there are number of questions are there. So we'll do problems, okay? So we'll do few problems. Okay, let's start. Shall we start? So a object 3 centimeter high is placed at a distance. So placed at a distance of 9 centimeter from a concave mirror. Okay, so concave mirror of focal length focal length focal length 18 centimeter. So calculate the position of the object. Calculate the position of the image. Position of the image form. Okay, so just to try to solve this one. Try to solve this problem. That's short, very important. Okay, so try to solve this one problem. So here you can see they already mentioned it is concave mirror. Was the convex mirror? Here already mentioned, right? It is concave mirror. Concave mirror. So focal length, see, an object height 3 centimeter high is placed at a distance. So object distance is equal to 9 centimeter. Anyway, concave mirror is like this. Okay, object is placed. And here, so the focal length is, so minus 8. So anyway, object must be placed in front of the mirror. And here you need to understand one thing. So focal length is for concave mirror is 18. So the question itself they given. Focal length is 18 centimeter. Then object is 9 means, so the object is placed here. Then what is the meaning of this one? That means the image will form behind the mirror. Already this is fixed. But we have to find out the position of the image. We have to find the position of the image. So that is left. Okay. So here you can observe one thing. Already they given object distance is 9 centimeter, focal length is minus 8 centimeter, 18 centimeter. Means focal length is 18 centimeter, object distance is 9 centimeter. Then the image must be formed behind the mirror. Okay, right. So now you can see here. You can see. So 1 by f equal to, formula is 1 by f equal to 1 by v plus 1 by u. So 1 by v equal to 1 by f minus 1 by u. So substitute the value 1 by minus 18. So minus 9. Then you will get 1 by v equal to 1 by 18 plus 1 by 9. Then you will get minus 1 plus 2 by 18. Then you will get how much? How much value you will get? Okay. Then the answer is 1 by 18. That is nothing but v equal to 18. V equal to 18 centimeter behind the mirror. That is positive. Anyway, positive only, right? So that is the answer. That is the answer. So let me know. So if you have any doubt, just check once. It's very easily. First, identify an object 3 centimeter high is placed at a distance of 9 centimeter from concave mirror. From the concave mirror, how much distance? 9 centimeter, right? And focal length is given. Focal length is 18 centimeter. Calculate the position of the image formed. So that is the answer. Any doubt? So if you know the answer, let me know. Is it correct or wrong? Just check once. So if you like the content, if you like the channel, you can do like, share and subscribe to Student the Brand. So now we'll do one more question. One more question. So just try. So I'll give one more question. Okay. So these problems are very important. This type of problems they will ask in the exam. So we'll do one more problem. An object is placed. So next one is an object is placed. Question is an object is placed. An object is placed an object is placed in front of a concave mirror, in front of a concave mirror of focal length, concave mirror of focal length 30 centimeter, focal length of 30 centimeter, focal length of 30 centimeter. The virtual image the virtual image of the object, the virtual image of the object is obtained at a distance 20 centimeter from the mirror, calculate the position of the image, position of the object. So this is the question. Check once. We have to find the position of an object is placed in front of concave mirror of focal length 30 centimeter. This is 30 centimeter. 30 centimeter. The virtual image of the object is obtained at a distance 20 centimeter from the mirror. Okay, calculate the position of the object. Yes, this is the question. So try to identify what is the answer. Okay, just check once. So thank you so much. We'll see you in the next class.